Let us try another examples for the probability. If the probability of any workday, a garage will get 10 to 20, 21 to 30, 31 to 40, and over 40 cars to service are 0.2, 0.35, 0.25, and 0.12 respectively. What is the probability that on a given workday the garage get at least 21 cars to service? To solve these questions, first we need to organize the numbers, which can be divided into this category, and the probability is listed here. The probability of getting less than 10 cars is not given, but we know that the summations of the probability will be equals to 1.0. We will need to determine the probability that the garage will get at least 21 cars to service. With that, we are looking into these three categories. The probability of getting at least 21 cars will be the summations of these three categories, which is equals to 0.72. If you ask to determine the probability of getting less than 10 cars, it is actually obtained by minusing 1 with all this probability. You will be able to determine the probability of less than 10 cars. Next example. In tossing a fair dice, what is the probability of getting an odd number or a number less than 4? The relationship is OR. That means it will be the combined conditions of the two types of event. The odd number will consist of 1, 3, and 5. The number less than 4 will consist of number 1, 2, and 3. The event of an odd number or a number less than 4 will be all the numbers that appear within the two events, which is equals to 1, 2, 3, and 5. Total number of 4 events. As for the number of space will be equals to 6. The probability will be equals to 4 divided by 6. And the answer will be equals to 2 out of 3. Next, we try another example. In producing screws, let A mean screw too thin, B means screw too short. The probability of A is equals to 0.1, and the probability of B within A is equals to 0.2. What is the probability that the screw that we pick randomly from the lot produced will both be too slim and too short? To understand the situations, let us look into the diagram here. This circle represents all the screws. This represents the normal screw, while this circle represents the screw which is too slim. The area of this circle will represent the probability of 0.1. That means out of all the screws here, the normal will be 0.9, while the screw which is too thin will be equals to 0.1. And within the group of screws which is too thin, 0.2 is also having the screw which is too short. That means 20% out of the group which is too slim is also too short. To determine the screw which is too thin and too short, we will multiply the probabilities. which is equals to 0.1, which is too slim, multiply 0.2 out of that 0.1. Therefore, you will get the probability of 0.02. In another word, there will be about 2% of the screw out of all the screw here will be at the same time too thin and too short. Next, let us try another example. A box contains 10 screws, 3 of which are defective. 2 screws are drawn at random. Find the probability that neither of the 2 screws is defective with and without replacement. In order to solve these questions, first we need to know the concept of with and without replacement. Let us look into the tree diagram here. You have 10 screws here. There will be 2 times of drawing the screw. While you are drawing the first time, you know that there will be 7 normal screws and 3 screws which is defective. Once you have drawn out the screws and you put it back before your second draw, that means it will be with replacement. Regardless what type of screw that you have drawn during the first round, if you put it back, the total number of screws will remain the same as 7 and 3. In the case that there is no replacement, after you have drawn one of the screws, the total number of screws will reduce. If during the first draw you have drawn the normal screw, there will be only 6 normal screws during the second draw. If during the first draw you have drawn the defective screw, that means the number of defective screws will reduce to 2 during the second draw. Based on the tree diagram here, you are interested with none of the screws are defective. It means you are drawing the normal screw and the normal screw for both of the draw. If you replace back the screw after the first draw, the probability will be 7 out of total 10 multiply the 7 out of total 10. The probability will be equals to 0.47. In the case that without replacement, you are looking on the normal and the normal screws, your probability now it will be 7 out of 10 and 6 out of 9. The 6 here is because you have already drawn one of the normal screw, and the 9 here is actually due to 6 normal screw plus the defective screw. With that, your probability of getting the both screw which is not defective without replacement will be equals to 0.49.